This is Dr. Carroll with another video. Today's video is about C-style strings. You're probably familiar with C++ strings, the kind that you need to do a pound include string class to get at. But now we're going to talk about C-style strings. C-style strings are really just strings that are char arrays. There's not much special to them except one exception. So a char array, we could have a car make, and let's say we're going to give it 16 spots to allocate. And so let's see, what would be in my garage? Let's just capture the make that would be in my garage, and that's how we'd assign it. There's some other ways we can do it. We can use this notation, and we could, for example, say we want to store banana. Now with banana, there's something different going on than what we just did with the car make, the fruit array. With banana, this array is actually 1, 2, 3, 4, 5, 6, 7 characters long. It puts a null character is the name of it, and that's represented by a \0 at the end of the array. And so in some ways this is very nice because it's automatically going to put that null character. This is the same as if we spelled everything out and like this. We specified, hey, this is going to be an array, and here's the array. We're going to initialize it with a B-A-N-A-N-A, and then explicitly putting the null character. These two are the same. So, and now that we've done that, we probably want to go back and add in the null character here so that it'll behave like a C-style string. So C-style strings are char arrays with the null character at the end. If there's not a null character at the end, it's not a true C-style string, and you'll run into problems. Okay, so that's how we declare arrays that are of a fixed size. But what if we wanted to use a dynamically allocated array? For example, a car model. So then we would declare a char array, car model, and then we could do car model equals new char 32. And then let's see, what would be the other car model? Maybe in my garage would say, I don't know, maybe that would work as the car model in my garage. So an important header file to know with dealing with C-style strings is string.h. Now this is not string, but string.h, which is for C-style strings. So if we just Googled that, we would come up with something like this from c++.com. Here's a number of functions that you get access to when you pound include string.h. I want to point out a couple, like string copy one string to another. Here we, let me get this at the top. Here we have a destination and a source, and notice the source is constant. What we're going to do is we're going to read out of the source and assign it to the destination, and the return type just gives you a convenience pointer back to destination. Now a question you might ask is, what if destination has less space allocated or reserved for it than source? What might happen? Buffer overflows, security problems, bad memory errors, things like that. So when possible, which is just about always, use string n copy. The n stands for the number of characters because it's a string. So it takes an extra argument here, and that's the number of characters to copy. So you can set that equal to the length of the destination array so that you don't overstep those bounds. Slight difference, but important security feature. So just get in the habit of, instead of using string copy, to use string n copy. Similarly, you'll notice with, for example, if you're going to concatenate two strings, you can do a string n concatenate so that you don't overflow the allocated space. There's other important things like string compare to walk through the two C-style strings and compare them and return. You can look for certain occurrences within the C-style string and other and string length is one of the most commonly used ones. And what it does is it returns the length of the C-style string here. It's just constant. We're not going to modify it, and it's going to return a positive integer. So C-style strings are just character arrays, and consequently you can use memcopy with them and memmove and things like that. That can be very helpful for C-style strings, but more appropriately for other arrays. But you get all of that with the string.h. Okay, so how can we convert back and forth between C-style strings and C++ strings? First, let's go the direction of going from a C-style string to a C++. So we have string, fruit, C++ string to differentiate. And of course, we've done a pound include string to get at that. And then we might have fruit from up above. Alternatively, we could use the constructor notation. That might feel a little better to do something like that. Now, to go the other way, with a fruit C++ string, we can do something like this, C-style string, and be able to access the C-style string of it to assign to a C string. In C++ 98, but not in C++ 11, fstream open required a char star. So you might have given it a string, for example, in a lab, but the compiler complained requiring that it had a char star, a C-style string instead. So then which to use? Well, C-style strings are safer and have more helper methods, but they have more overhead. So if you're not really concerned about that small difference in overhead, go ahead and use C++ strings. That's it.